present about handling class imbalance in binary classification. We were using comparative study between SMOTE for sensitive learning and balanced Bayesian. Firstly, we'll discuss about the exploratory analysis and exploratory analysis to PCA, the debt baseline models, and then techniques to correct the imbalance. After that, the comparison of the model. Firstly, for the exploratory part, the data have 1,500 observation with 15 numeric features. Our target is a binary target. However, it has a very imbalanced class, where class 0 have over 90% of the number class. What happens when there is imbalance in class 0 and 1 is the minority? Usually the classifier will favor in majority class. So a model will produce high accuracy because it tends to it tends to predict all the majority class. Next. After that, we will study about the PCA. For the PCA, firstly, we will plot the script plot. From the script plot, there is 90% original information where at least 9 principal components are required. This data set are complex, multi-dimensional features and can be simplified into 2D presentation without significant information loss. While with the 2D script plot, only 36% of the variation can be explained by the PC1 and PC2. And we can plot the PC1 and PC2 to visualize the class. And we can see from the PCA to D visualization here, the structure can be seen as non-linearly separable. Next. Part B. Firstly, we will run the baseline model to check overall accuracy. But here we can see the accuracy is misleading for this imbalance problem because the test set contains 284 majority class observation and only 16 minority class. Logistic regression has 95% accuracy, but recall for the minority is less than 1%, meaning it correctly detects 1 out of 16 minority class. While decision tree has slightly lower accuracy, but it identifies 6 out of 16 minority class. So the recall is and F1 score is better. Next, I pass to my partner, which is Mujahid, to present the next one.
Okay, thank you, Hani. So as we can see from baseline models previously, they don't have a great recall value or F1 score. So 3 different methods is applied to tackle the imbalanced datasets. First is called SMOTE, which stands for Synthetic Minority Oversampling Technique. So basically, this technique is basically identify a minority data, and then we find the nearest data point, and we create a new synthetic example in between those data points, and then we do this for all minority datasets. So this will create a balanced amount of datasets between the minority as well as the majority. So for logistic regression baseline model that have been applied SMOTE, so the recall improved from 0.06 to 0.69, as now it can detect 11 out of 16 minority classes. But we can see that minority precision drops from 1 to 0.14. This is explained by it can only the predicted label, which is class 1. The true label can only predict like 11 out of the whole 80. So that's why it drops from 1 to 0.14. And then you can see that the accuracy falls as well from 0.95 to 0.75. but the F1 score improved from the baseline model from 0.11 to 0.23. For decision tree, the recall improved um, compared to the baseline models, and as it detects 9 out of 60 minority classes, but then the precision drops up to 0.28, as well as the accuracy falls from 0.94 to 0.9. However, in this case, F1 score drops from 0.39 to 0.37. As we can see from the AUC, from the ROC curve, the AUC for the SMOTE for logistic regression that applies a SMOTE technique actually is less it's not better than the baseline. As you can see, the AUC is only 0.7691 as compared to 0.7771. And for decision tree, the SMOTE technique that applies on the baseline model is much better in terms of the AUC, which is 0.74 as compared to 0.67 for the baseline model. Next slide, please. And for cost-sensitive learning, so basically this is cost-sensitive learning is a method where it imposes a specific cost for specific type of false, either false positive or false negative. So in this case, let's say if we treat a class 1 as positive, and then if the actual value is class 1, but the model predict as class 0, then it's called considered as false negative. Then it is not good. So in this case, false negative will be more costly as compared to false positive. So for logistic regression that applies cost sensitive technique, so the recall improved to 0.63 as it detects 11 is 10 out of 16 minority class, but the precision again dropped to 0.13, and then the accuracy falls as well to 0.76 as compared to 0.95 from the baseline model, but the F1 score improved from to 0.22. For the decision tree model, the recall drops instead of going up, the recall drops to 0.32, and this is as it detects only 5 out of 16 minority class, but then the precision drops as well, 0.29, and the accuracy falls from 0.94 to 0.92, just a slight drop. But because of the drop of in recall and precision, the F1 score drops to from 0.39 to 0.3. As we can see that the AUC for logistic regression is is again is less it's not a better model compared to the baseline model, but for the and again the same for applies for cost sensitive technique that applies on the baseline model performs better because it has a greater AUC value, which is 0.67 compared to 0.6351. Next slide, please. And then for balance bagging, so balance bagging is technique is basically we we perform bootstrap sample where we split the sample into several samples, and then from each sample we undersample the majority, but we keep the minority sample. So for this subset of sample, it will create a balanced data set, of initially minority data set, and now it will become more balanced between the majority data and the minority data. So for logistic regression, using the balanced bagging method, the recall improved to 0.75. It detects more, which is 12 out of 16 minority class. The precision drops to 0.15, and the accuracy also drops to 0.76. But the F1 score improved compared to baseline model without the balance bagging technique, which improved to only 0.25. For decision tree, the recall improved overall to 0.6, and but the precision drops from 0.4 to 0.28, and the accuracy falls only slightly. Just accuracy falls only slightly from 0.94 to 0.89. However, the F1 score still drops from 0.39 to 0.38. So as we can see from the AUC value here, the balance bagging that applies to the logistic regression model, it has a slightly higher AUC value, which is 0.78 as compared to 0.7771 from the baseline model. And for the decision tree that applies balance bagging technique, its AUC is way better compared to the baseline model, which is 0.85 as compared to 0.67 from the baseline model. Next, I will pass to my colleague Muzaffar to continue further.
Thank you, Mujahid. So I will talk about the comparison model for part C. So as the models have already been talked about by Hani and Mujahid, so in this section we only compare. So firstly, we compare the models that we have already created, and one of the key metric that we usually start to look into is the AUC, which is the area under the curve in the ROC curve plotting. And what we find is that firstly, the balance bagging of decision tree is the best model so far based on this metric, AUC metric. And if you can see, the accuracy is also quite high, quite decent at 89%, where the recall is also very high at 62%. But the problem is because last time we only use the test set, only have 16 minority cases. So the next step, what we do is we use cross validation to increase the test set um, fivefold. So that means we will have about 80 minority cases, 16 times 5. So rerunning all of the methods with fivefold cross validation, we actually get almost the same decision. So another metric that we usually see, if you look at the table at the bottom here, is F1 score, which is also another balance measurement. It also points to balance bagging decision tree to be the best one among the three methods that we have studied. Um, but there's also other ways to choose the model. It's based on actually the objective of the model. So in this case, our question did not define what is the objective. Is it a very critical to detect all the minority classes? If it is, then model comparison should be done based on recall. So if we look at the recall scores, and this is another view of the same five cross validation modeling model technique, what we find is that if you sort the data based on recall, we find that actually logistic regression is the best because logistic regression able to detect about 68% of the minority classes. Both SMOTE and cost sensitive is almost the same, and the accuracy also is quite decent at 72%. So it's not that bad. As you can see here, we have every fold we have 16 minority classes, and on average per minority classes, we can detect 11 cases. So that is quite a good portion already. So if we really concern on the minority class, maybe the minority class is a terrorist want to enter the aeroplane. So it's very critical that we detect the minority. Then this would be the model that we want to pick. Lastly, there's a third method to detect, to choose which model is the best. This method, we call it the precision recall curve plot. And this is basically trying to find the balance between recall and precision so that we can gain both, the best of both worlds. So this is a more balanced view. And what we can see from here, you can see that the decision tree, balance bagging decision tree, covers the most area, as you can see from this bulge here. So the AP is 0.39, which is the average precision, average 0.39, and then followed by, which is shown to be the best model if we use precision recall curve as our key metric. And then secondly, cost sensitive logistic regression is the second best, which will still show up in our model. So in conclusion, what we can say is that based on the objective, um, we need to choose which model is the best for our objective. But for this study, what we give the conclusion is balance bagging decision tree gives the best overall trade-off because it gives the best F1 score and the best average precision in the cross-validation set. But for cost-sensitive logistic regression, it still can be used because it has the highest recall. So making it the best when missing minority case is a big concern. That's all from our team. Thank you for listening.